Hello everyone, I'm Sriram and this is lesson over AP Chem factors affecting rates. So basically this is like the less math part of this unit. It's more about like theory and like the scientific explanations of why the actions occur and how fast they occur, what changes that. So essentially there's this collision theory. It's just a theory. And it's basically saying for a reaction, reactants must collide with each other and need have enough energy, technically kinetic energy. So I'm just going to write it as Ke to break bonds. And this is from thermodynamics, the thermochemistry unit we did. How we needed like us extra energy to break bonds and then form the new bonds. So I have enough kinetic energy to break bonds. And in correct attachment, correct geometric arrangement. Because if we try to like put two pieces together, like two Legos together, you kind of need it to be in the right orientation, usually. So effective coalitions are basic coalitions that allow reactants to be converted to products. As more effective collisions happen, that easily means that we make more products. So more effective collisions, more the rate of reaction increases. That's basically the main thing. So how can we affect the rate? Well, there are six main ways. So the first one is reactant, because more complex reactants tend to be uh, sorry, more reactive elements are able to react quicker, and the faster you're able to react, the quicker the rate is. So metals get more reactive, and this is something you probably need to know. So metals reactivity, and it's just like a periodic trend. So like the other four of them, like atomic size, ionic energy, ionization energy, so on. Metal reactants, so metal reactivity actually increases as you go down a group. So i.e. Cs is more reactive than sodium. And then non-metal reactivity decreases actually. So non-metals are the opposite as you go down a group. Down a group. So what does this mean? This means that chlorine is actually less reactive than fluorine. So that's the first one, nature of reactants. Second one is the concentration. And you learned about concentration basically with dilution. You know, when you dilute water, there's less particles of that solute per the whole solvent. So higher concentration means more stuff, more reactants. More reactants means more collisions. So higher concentration, higher concentration means faster rate. And this unit, all probably 99% of the time, you're going to be expressing concentration in molarity, so moles per liters. And it's kind of intuitive because like you have more things, a higher chance of effective collisions. And once again, more effective collisions just means you'll have a faster rate. Okay, surface area. This is kind of um, something to remember. So surface area So rates increase with more surface area because there's a larger space to react with. Oh, this is another part you also need to know. Smaller particle size. So breaking a solid into smaller pieces can allow it to allow more molecules, so more of other reactants to come and um, mix and collide at the same time. Same with surface area, that's just more space um, for other reactants to join and collide and react. Next up is pressure. And main headline here is only affects gases. This does not affect solids and liquids. And basically, pressure means mole P means more means mole effective collisions. So faster rate. And remember, you can only increase pressure generally by decreasing volume. The law between P1 V1 and P2 V2. So you can think of it as like, oh, more pressure means less volume in general. So meaning like there's only so much room now for molecules to bounce around. Meaning there's a higher chance that two molecules will see each other and collide. And it's probably a higher chance of being effective, so it'll increase the rate of reaction. Um, Temperature, kind of same thing. Reactions increase as temperature increases. So faster moving particles collide more frequently. Remember, because kinetic energy we already showed like unit 2, it's like 3 by 2 all teeth, the all the 1/2 mv squared solving for RMS, that stuff. That's where the equation came from. So just remember, as temperature increases, kinetic energy increases, meaning molecules move faster, so higher chance of effective collisions. So that's why. Catalyst. This is the last one. This is kind of like the odd one out. So catalyst is just adding a whole another thing to a reaction. Um, but the thing is, catalysts are substances, are substances that speed up reactions. But the thing is, the hook is they don't get consumed. So this is why it's kind of like very different from like the other five factors, which are like pressure, temperature, volume, concentration, and reactant nature. This is a whole another addition, another particle being added to like spectate and like but speed up the reaction. And if you have taken AP Bio, you probably know what an enzyme is, and they're basically biological catalysts. Right? And I think that's pretty much it for this lesson. Thank you.